Hello everyone, before I begin I would like to introduce myself to you. My name is Nidal Mohsin from Mohammed V University in Rabat. I'm a researcher and PhD student in Laboratory of Mechanics and Technology in ENSAM Rabat. So the purpose of today's presentation is to present a simulation and experimental study of novel cascade solar cell. Shortage of drinking water, limited source, and inadequate access to clean water are the most invasive problem distressing people. Since saline water covers the most of the water film coverage, about 97% of Earth's water, converting brackish water to fresh water is one of the best solutions to water shortage issue. So solar desalination is the perfect process for distilling saline water by using solar energy. Because Morocco has an important solar energy potential, about 3,000 hours per year, which is clean and has no adverse effects on environment. During my presentation, I will follow the following plan. In system description, a new approach to design of solar cell absorber plate was developed. In design modeled with ANSYS, a model was developed to evaluate the solar cell performance before the construction and the experimental process. So before concluding the presentation in experimental and simulation results, an experimental process was carried out to verify the new device production. Principle of conventional cell comprises three steps. Solar radiation received is absorbed effectively by a black surface and the heat is transferred to the water in the basin. So the temperature of glass cover increases and it increases the rate of evaporation. So a sloping transparent glass cover is provided at the top and the water vapor produced by evaporation rises upward and condenses in the inner face of the glass cover, which is relatively cold. So solar cell is very simple device and cheaper than other form of desalination. However, in comparison with the other techniques, the yield of single basin solar cell is very low. So the investigation indicated that the depth of water in solar cell inversely affects the productivity of the steel. So reducing the brain depth in the steel improves the productivity. Recently, cascade solar steel have received much attention due to higher productivity than the other basin types. So the steepest steel is an inclined type has the same construction of the conventional steel. In addition, the absorber plate is made of number of steps. The stepped solar cell tip offering minimum depth of water, better water orientation with respect to the transparent cover, and minimum air gap water glass, so that can lead to increase the basin water temperature of stepped solar cell. The ordinary form of cascade solar cell had an absorber plate with horizontal and vertical surface, and the angle between the two surfaces was about 90 degrees. So in the new design, the vertical surface of absorber plate is inclined with angle of 35 degrees for better orientation relative to the sun. So our pattern is consisted horizontal and vertical inclined type of absorber plate, and the angle between the two surfaces was about 145 degrees. In order to improve the performance of cascade solar cell, the flow velocity of the water in the absorber plate should be minimized. Therefore, in the new design of the slope absorber plate, we added different wears to the surface of absorption. Solar cell has a top cover made of glass. The glass cover has two functions. Firstly, solar radiation passes through the glass cover, which prevents the radiation being transmitted by the inner face of the basin with a low temperature. And secondly, glass cover presents a condensing surface of the steam. So we use an inclined glass cover more than 25 degrees for two reasons: to provide better orientation relative to the sun and to facilitate the run of the condensed water to the collector. So the basin is made of metal, aluminium, and the thermal insulation is achieved by coating inside the basin. So the absorber plate is made of aluminium and painted black, consisted horizontal and sloped surface with black metal buffle in the inner face. The new construction of the absorber plate presents the following advantage: better absorption of solar radiation, minimum depth of water, and heating water quickly. 3D geometry of solar cell was modeled using ANSYS design modeler with all geometrical constraints, same as the experimental setup. The physical model of the building was measured using 3D hexagonal meshing consists of total 1.5 million cell elements at a grow rate of 1.2 in ANSYS workbench meshing. A grid independent test has been done to check the mesh size for the model. The convergence criteria were achieved for continuity, velocity, and the energy equation at each time steps. Appropriate boundary conditions were specified at all boundaries to solve the continuity and moment equation. So the received solar radiation by the basin as well as water and glass temperature were based according to the solar calculation in fair weather condition. So the constant temperature and boundary conditions were enforced in glass bottom and the collecting surface. So the solar intensity was based upon the absorber factor and emissivity of glass, water, and bottom. And for the heat transfer coefficient of side walls was calculated and maintained constant for the overall process. The CFD simulation had runtime of 10 hours because of higher number of time steps and computer restriction. In this experimental setup, the cascade solar cell is fed by 25 liters of brackish water and 6 thermocouples are installed at the absorption surface and 3 in the inner face of the glass cover. This process using for obtaining the solution for the finite element model that generated in the processor. So the numerical studies were based on the following assumption. Thermophysical property of aluminum, glass, and air remain constant during the process, and the thermal contact between glass solar cell basin walls and its surrounding is perfect. So the solar cell wall temperature is considered equal and undisturbed. The figure 4, 5, and 6 present the contours of absorber temperature at various time intervals. So the effects of sun move during the day can be clearly seen on the temperature profile of the absorber plots. As the solar intensity increases with time, the temperature of absorber plots also increases up to the maximum at 3 p.m. So after that, it decreases as the solar intensity decreases. Figure 7 shows the absorber temperature of cascade solar cell. It follows the trend of intensity of solar radiation. The simulation outcomes have been compared with the experimental data, all through the reading not exactly matched, but they follow the similar pattern. So the most likely reason for this variation is that the intensity of solar radiation taken in the simulation doesn't account for a natural attenuation. For the figure 8, the simulation results of solar intensity have been compared with the experimental data. So the results compared are well perfectly matched and it follows a similar pattern. The figure 9 represents the variation of absorber plot temperature and solar intensity. So the absorber plot temperature has shown in figure 9 increase with an increase of solar radiation. So the temperature can reach a 60 Celsius degree for 900 of solar intensity, which is an important value of temperature in comparison with the other cells results. So for the figure 10, as the intensity of solar radiation creates more distilled water it produces due to higher temperature. So after reaching its maximum, the productivity falls as the intensity of solar radiation drops. So the simulation results were compared with the experimental data and it observed that the experimental and simulated data followed a similar pattern. In this project, a new type of inclined solar cell with stepped absorber plot, slope surface, and baffle was proposed, fabricated, and tested in order to develop the simple and cheap step of desalination. So the simulation results showed that the computational fluid dynamics is a powerful tool for design, parametric analysis, and difficulties removal for a cascade solar cell. So for the future work can be done with changing the orientation of solar cell and integrate more buffer to minimize the depth of water and considering the other different design parameters. And thanks for your attention.